Welcome to section 422. We're going to be talking about the significance of h and k, a little review of how to write the different functions, and then we'll be talking about another way to work with linear functions as well. So a real quick review, remember when a is less than 0, there's an x-axis reflection. When the absolute value of a is greater than 1, that's our vertical stretch. When the absolute value of a is between 0 and 1, that's our vertical compression. And h, we shift left if it's negative, right if it's a positive, and k is our shifting down if it's a negative, and up if it's a positive. So keep that in mind as we're working on the first few problems. So for one, it's a quadratic function. So we know we have an x squared. Stretch vertically by 3. So that tells us that a is 3. Shifted left 3. So h is a negative 3. And then down 4. So k equals negative 4. For a quadratic, y equals a times the quantity of x minus h squared plus k. And then we fill in our values. Y equals 3 times x minus negative 3 squared plus negative 4. Y equals 3, x plus 3 squared minus 4. There is our quadratic function. For number 2, it's a cubic function, so it's at x cubed, reflected along the x-axis, so that tells us a is a negative. Then it's compressed vertically by 1/3, so it's a negative 1/3. We're shifting up 5. So h, we're not going left and right at all, so it's 0. And k, we're going up 5, so k is 5. Our cubic function is in the form y equals a times x minus h cubed plus k. So y equals negative 1/3 x minus 0 cubed plus 5. Now we can clean this up. Negative 1/3, and then we can just put x cubed plus 5. Number 3 is a hyperbola. That's that 1 over x. Now we're shifting to the right 6 and down 2. So a, nothing's happening with a stretch, compression, or reflection, so a is 1. H, we're going right 6, so h is 6. And k, we're going down 2, so it's a negative 2. So this is in the form of y equals a times the quantity of 1 over x minus h plus k. A is 1 over x minus 6, and then plus negative 2. So we clean that up. We don't need the 1 on the outside, so it's just 1 over the quantity of x minus 6 minus 2. There's our hyperbola, that rational function. Number 4 is a quadratic again, so think x squared, reflected along the x-axis, and compressed vertically by 2/5. So a, it's a negative because of the reflection, and a 2/5 because of the compression. And then h, we're shifting to the right 7. H is 7. And k, we're not going up or down, so it's 0. Y equals a, x minus h squared plus k. So y equals negative 2/5 x minus 7 squared, and then plus 0, so y equals negative 2/5 x minus 7 squared. Number 5 is an absolute value function. So it's got a reflection along the x-axis and stretched vertically by 4. So a, it's a negative because of the reflection, and a 4 because of the stretch. Then it's going to go to the right 7, so h is 7, and k, we're going up 12, so k is 12. So y equals a, absolute value of x minus h, and then plus k. So y equals -4, absolute value of x minus 7 plus 12. And there is our absolute value function. And then the cubic function, so x cubed. A, there's no stretch, compression, or reflection. So A is 1. H, we're going left 10, so it's a -10. And K is up 20, so it's a +20. So y equals A, x minus h cubed plus k. So y equals 1, which we don't really need. X minus -10 cubed plus 20. So we write that again, y equals the quantity of x plus 10 cubed plus 20. Good. Now we're going to talk about linear functions. Now, the parent function for a linear, y equals a times the quantity of x minus h plus k. It really still works in the same way, but we don't normally, well, we do normally write it that way, but we kind of change it around. We have also what's called point slope form. And point slope form is y minus y1 equals m times the quantity of x minus x1. If you think about the slope formula, m equals y2 minus y1 over x2 minus x1. If we were to put that over 1 and cross multiply, we'd get y2 minus y1 equals m times the quantity of x2 minus x1. It's really just a rewrite of the slope formula. And we'll use that for the next few problems. So we're going to use that point slope form. Y minus y1 equals m x minus x1. It's good when you're given a point and a slope. So now our slope is 4/5 and the point 3, 9. So what we do, that's going to be our x1, y1, and that's going to be our m. So y minus 9 equals 4/5 x minus 3. Now what we want to do is we're going to get the y by itself. So we're going to distribute the 4/5. So y minus 9 equals 4/5 x, and 4/5 times -3 is -12/5. And then we're going to add 9 to both sides. So y equals 4/5 x minus 12/5. And now that's a 9 over 1. So to get a common denominator, we're going to multiply by 5 over 5. So it's going to be plus 45/5. So y equals 4/5 x. -12 plus 45 is a positive 33 over 5. There's our equation in point slope form. Just another way to write the equation of a line, another way to find the equation of a line. Let's try it again. Number 8. Here's our x1, y1, that's our point, and our slope is -3. So y minus y1 equals m, x minus x1. So we have y minus 4 equals -3, x minus 5. Y minus 4, and distribute the -3, we get -3x plus 15. And then we just add 4 to both sides. Y equals -3x plus 19. And we're done. I think it's a nice way that we don't have to go and solve for b and then substitute everything back in. It's all done for us. Now in problem number 9, we're not given the slope, but we can find the slope. We can use that slope formula, y sub 2 minus y sub 1, x sub 2 minus x sub 1. So it's going to be 10 minus -2 over 2 minus 5. So our slope, 10 minus -2 is a positive 12 over a -3. So our slope is negative 4. So we can pick either one of the points. I'm going to pick the point 2 and 10. So y minus 10 equals negative 4, x minus 2. Y minus 10 equals negative 4x plus 8. And then we just add 10 to both sides. Y equals negative 4x plus 18. And there's our point slope form to get our equation in slope intercept form. It's just another way to do it. It's just adding another technique. Number 10, same type of problem, find the slope. Y sub 2 minus y sub 1, x sub 2 minus x sub 1. Negative 8 minus 1, negative 3 minus 6. Negative 9 over negative 9, so our slope is a positive 1. We can pick either one of the 2 points. I'm going to pick the 6 and the 1 because they're both positive, and that's what I feel like doing. Y minus y1, m, x minus x1, there's that point slope form. Y minus 1 equals 1 times x minus 6. Y minus 1 equals x minus 6. Add 1 to both sides. Y equals x minus 5. And there's our equation in that slope-intercept form. Okay. Thank you, and I will see you in the next video.